Okay, we're going to do a little bit of modelling with first order differential equations. So we're basically putting them into a real life, in inverted commas, because it's math situation. May well involve acceleration, velocity, displacement. I've also got another example that involves concentration of a liquid. But yeah, we'll just start by looking at the first order differential equations, and then we'll move into the second order ones after this, which will involve simple harmonic motion. Just as a quick recap, that if you differentiate the displacement, you get the velocity. So velocity is the rate of change in displacement, and acceleration is the rate of change in the velocity. And so you can integrate to work backwards. So displacement is the integral of velocity, and the velocity is the integral of the acceleration. We're integrating because we're solving first order differential equations. So we've got a particle P starting from rest at the origin, moves in a straight line where the acceleration equals 6 over t plus 2 squared, and we want to find the velocity. So the acceleration is the velocity differentiated with respect to time. And you'll notice we'll have a few variable changes with these questions as well, but you'll get used to that. And so from there, the velocity, just check your variables. So I've only got t's on this side. If I integrate both sides with respect to t, I can integrate all of this with respect to t, so I don't have to separate the variables on this question. So v is literally the integral of 6 over t plus 2 squared dt. That's 6 lots of the integral of t plus 2 to the minus 2 dt. Just because it's further maths, you don't have to overcomplicate it if you don't need to. We will do some revision on all those trig integrals soon. It's coming up, but don't worry too much about that for now. So for this one here, I can raise a power by 1, divide by the new power. And then you need to times by 1 over the coefficient of t. I'll write it in to remind you, but the coefficient of t in this case is just 1, so it's not going to make any difference. So this gives me, and then I've got plus c on there, minus 6 over t plus 2 plus c, and then we do have some initial conditions. So we're starting from rest at the origin. So when t equals 0, v equals 0. So 0 is equal to minus 6 over 2 plus c, and so c is equal to 3. And therefore velocity is equal to minus 6 over t plus 2 plus 3. So there's not, there's nothing to worry about in that example really at all. It's just contextualising it a little bit. It's the sort of thing you could probably do in maths, to be honest. And now we want to find the displacement from the origin when t equals 6. I've got my wobbly board, so that's a bit annoying. So find displacement from the origin when t equals 6. So we know that if we differentiate the displacement, we get the velocity, which is going to be 3 minus 6 over t plus 2. We've only got t's on this side, so I can integrate both sides with respect to t. We don't have to worry about separating the variables, and it's not a difficult thing to integrate. So displacement is equal to the integral of 3 minus 6 over t plus 2. So that is going to 3t minus 6 ln t plus 2. And then we need that plus c in there. And we know that it's starting from rest at the origin. So we also know that when t equals 0, the displacement is equal to 0. And that will enable us to find the constant of integration. So 0 is equal to 0 minus 6 ln 2 plus c, and so c is equal to 6 ln 2. Always make sure you find that c. It's really easy to sort of forget to do it when you're solving differential equations. So where are we at? We've got s equals 3t minus 6 ln t plus 2 plus 6 ln 2, and we want the displacement when t is equal to 6. S equals 18 minus 6 ln 8 plus 6 ln 2. I think you could probably just whack that into a calculator, but ln 8 is ln of 2 cubed. And then I can bring down that power. And that just tidies it all up a little bit. So the displacement is equal to 18 minus 12 ln 2 meters, if we're working in meters. So as a warm-up, this after half-term warm-up, if you could do a few of those, and then we'll look at bringing in some of the further maths techniques after that.